Hi everyone, today's objective is graphing factor form. If you have a quadratic equation in a factor form, you can set the factors equal to 0 and solve for x to find the x-intercepts. This will allow you to locate the axis of symmetry, which is in the middle of the 2 points. The axis of symmetry will tell you the x-coordinate of the vertex. Substituting the x-coordinate into the equation will locate the y-coordinate of the vertex. Today, what we're going to do is we are going to talk about the symmetry lines. Example 1, graph f of x equals x minus 2, x minus 6. Solve for the x. That is going to be using zero product property. X minus 2 equals 0, and then x minus 6 equals 0. And solve it. And then the second thing says graph the x solution on the graph. Go ahead, plot those 2 points on the graph. Then go ahead, finish off some of the things that you can do, and then we'll check back with your answer. So when you solve it, there's your x over equals 2, x equals 6, and that is what I did to plot it right here. X equal, you have x equals 2, x equals 6. And those are your x-intercept, and those are your zero product property. And coming back to here, then what's the next thing says? Change the function into a standard form, and the hint they give you is distribute property on the equation. So that's what I did. X minus 2 times x minus 6. I distribute them out and combine like term, and what happened is that's the equation of fx equals x squared minus 8x plus 12. That's the standard form compared to the factor form from above, which is x minus 2, x minus times x minus 6. So they mean the same thing. Then they say D, find the x symmetry using the equation in part C. The equation in part C also tells you A is 1, B is negative 8, C is 12. So I plug into negative B over 2A, and once I plug into negative B over 2A, I found out the x symmetry line is 4, and the second part, the y-coordinate, is going to be negative 4. So my vertex is 4 and negative 4, which is right here. That's my vertex. There's my vertex. So this is the x-coordinates, and this is the vertex, the y-coordinates. And then what you're going to do is the graph the parabola, and here's my parabola. Now symmetry line is x equals 4, which is from what you solve right here. But if you think about this, what they are saying, the symmetry line is in between right here. The symmetry line is in between the x-intercept, which is 2 and 6. What's halfway between 2 and 6? It is 4. And this will happen every single time. So if you want to, if they give you both x-intercepts, there will be a symmetry line through the middle of it. There will be always the situation between them. And then what you're going to do is G, how were the coordinates of the x-intercept related to the factors of f of x? X-intercept are the solution of factors of fx, and that's what it is. That's example number 1. Looking on the next thing, if we know the two solution of quadratic equation, that's what we just did. Now we got the answers. So right here, we got the answers, right? X equals 2, x equals 6. Right here. This is what they are talking about. I have 2 and 6. How do I go back to the original equation that's giving it to you? If you take a look at it, how do we go from here to back up to here? Well, we are going to write the answer backwards. So this is a positive 2, this is a positive 6, and we're going to put it in and change the sign. Did you guys notice that? This is positive 6, become negative 6. This is positive 2, become negative 2. So that's what we're going to do for example number 2. So your equation is going to be x minus 3, opposite, and x minus a negative 4. So that is going to be a positive. So your equation is really x minus 3 times x plus 4, and then you multiply it out and you get the equation. Please finish your example 2a and try example 2b. So in this case, if you write it opposite, the solution is minus 3, and negative 4 is going to be minus a negative 4. And when you combine the negative become positive, x minus 3 times x plus 4. When you FOIL it, x squared plus x minus 12 equals 0 is the equation you get, and you can rewrite it in function notation form, right? B is trickier is because if you look at this problem, you have a half, and you have a -3. So that's no problem. X minus a -3. And then same thing here, x minus a 1/2. Same formula. The only difference is we are trying to get rid of that fraction. And then to get rid of that fraction, we need to put x over 1. And once you put x over 1, you have to have the same common denominator. And when you have the same common denominator, and once you find the denominator is the same, disappear. That's why it becomes 2 times x is 2x minus 1. And there's the new parenthesis. 2, when you FOIL it, 2x squared plus 6x, 2x times x, 2x squared, 2x times 3, 6x. -1 times x, -x. -1 times +3, that's going to be -3. Combine like term, there's your equation. Let me say it one more time. I have to find the common denominator for this. Once I have the same common denominator, the denominator is gone. So that's example 2, letter B. That's the tricky part. Example number 3. Find the vertex given the x-intercept of a quadratic equation. Since the x of symmetry forms a mirror image of the parabola and pass through the vertex. The x-coordinate of the vertex is the midpoint between the two x-intercepts. So what that means is I can just write here real quick graph x minus x plus 3, which is just the opposite, so that's x equals 3, and x minus 1 is opposite x plus equals 1. Now if you need to, anything with a little bit different forms, you can solve it. That's just x minus 1 equals 0 plus 1 plus 1 and x equals 1. So I'm going to graph it right away. To find the x-intercept, I solve it as x plus 3 equals 0. So that's going to be -3 on both sides, so x equals -3. And x minus 1, I wrote it out for you. And then so I sketched it right here. It's going to be 1 and -3. Now, so axis of symmetry line is the one that's in the middle. So in this case, it's this line right here. That is the x symmetry because that's 2 space to the 1, and that's 2 space to the -3. And because I know that x equals -1 right here, I am going to plug it in, -1. I'm going to plug into the original equation, and I get my vertex at -4. Y coordinates of the vertex. So therefore, the vertex is -1, -4, which is right down there. And you notice it is facing up. So there's how you graph the parabola. That's example number 3. Using the axis of symmetry to figure out where is my, between the two x-intercept, there's my x symmetry. So please try letter B and letter C. So from the B example, example number 3, I sketched the points that's -3. Now you are going to be very curious what happened to my other points, because everything is going to be the same because both answers are -3. Don't worry about that right now. We're going to talk about it pretty soon. So the next step, what you're going to do is the second step is to find the vertex. Don't forget, when you find the vertex, you have to make sure that you plug in the numbers, but we don't know where is the number because we only have x-intercept. So distribute the problems out, and I'm going to pause the video. So after you distribute, you get x squared plus 6x plus 9. So now what we can do is we can definitely do -b/2a to find the first part of my vertex. And you should know a is equal to 1, b is equal to 6, and c is equal to 9. And on top of it, you can also get the y-intercept. So that's going to be -b, which is 6, over 2 times 1. And when you finish, that's also -6/2 is -3. So actually, if you think about it, your x-intercept, which is the 2 points, is also the same as the x-axis. So then that is the line going down in the middle also. What does this look like? So what we're going to do now is we have a C, which is the y-intercept at 9, and we are going to go up here and give me the 9. And then so go to the other side, that's going to be 9. So there is my parabola. So it is a little bit different because my x-intercept is the same thing is my x-axis. But because I distributed, I have the y-intercept to give me the other half of parabola. So this parabola actually look like a tulip coming out of the bottom of the dirt. Okay, so there's no touching it with both of them. Okay, there's no 2x intercept. And eventually I'm going to show you how you can decide, is it going to be 1? Is it going to be 2, which is most of you guys done? And then there's also a possibility of none. What would that look like? Alrighty, so now going on to do letter C. Let's label the points. So this is x is going to be at -3, that's your axis of symmetry, and the vertex is going to be 0, no, I'm sorry, -3, 0, and then your y-intercept is going to be 0, 9, and over here is going to be -6 and 9, right? And the reason I pick -6 again is because it's 3 away from the intersecting line, and so they're to the right, so therefore 3 space to the intersecting line to the other side, which is on the left. Okay, please try letter C, and we'll pause and talk about it. C says x minus 5, graph f of x equals x minus 5 and x minus 1. So your x-intercept is going to be this, x equals 5 and x equals +1. So I graphed it right here on the number lines. And then I just take the symmetry line. So symmetry line, this line is going to be in between the 1 and the 5. So there's symmetry line. So that symmetry line become x equals 3. I just cut it in half. So because that symmetry line is what you use to plug into, that's the x coordinates of your vertex. So what I did is I take the x equals 3 right here, and I plug it in to the problems right here. Original question, so that becomes 3 minus 5 and 3 minus 1 right here. And when you simplify, you get -4. That's the y coordinates of your vertex. And then so therefore your vertex is 3 and -4, which is right here. Vertex is 3, -4. And then right here, that's going to be 5, 0 for the first x-intercept. And then the second one is going to be at 1, 0. That's your second intercept. And that is how you do letter C and graphing the parabola. So for example number 4, I would like to work through it with you guys. I know I wrote down everything, but please pay attention because you have to know how to do this. All right, to start it off, let's read the question. And the question goes, James Bond stands on top of the 240-foot building and throws a film canister upward to a fellow agent in a helicopter 16 feet above the building. The height of the film above the ground, t seconds, later is given by a formula h equals -16t squared plus 32t plus 240. So here's my little picture with a helicopter. Here is the building, and here is James Bond. Now, James Bond is gonna throw 16 feet up to the agent that's in the helicopter. And there's my helicopter. And then so in this case, you should be able to see there's a parabola. And then I am going to show you when I put this equation right here into the parabola, into the calculator. This is what I got. I got a picture look like this. And yes, the parabola is not centered. All right, so then I also know that my A is -16, my B is 32, my C is 240. That's another thing. So when they say find the vertex, you can do it two ways. You can do it by calculation, which is I find -b over 2a and then plug it in. Or I can actually use the button on the calculator that says the maximum, because that's the highest point on the helicopter. So that's why I know is a maximum. Is the vertex maximum or minimum? That is why, because the parabola is upside down. Then when they say how long will it take the film canister to reach the agent in the helicopter? Well, because that is the symmetry line coming through from going top and bottom, if you can see the blue line, that's going to be the highest point. And since that's the highest point, that's going to be 1 second right here on the vertex. Okay, and then what happened here is, if you definitely check, you can see that is 240 plus another 16, which is going to be the highest point, 256. So how long would it take for the film canister to reach the agent in the helicopter? It takes 1 second right here. All right, because that's the highest point. And the next thing it says E, if the agent misses the canister, when will they pass James Bond on the way out? Now, since James Bond was the one that threw up, it has to come down. And then because you know there's a symmetry line, it takes 1 second for James Bond to throw up to the helicopter. So therefore, it also takes James Bond another second to get it back down. So because they are symmetrical. So James Bond will take 2 seconds to pass down because it looks like this. It goes up and come down. Here's James Bond. This is James Bond, and this is coming down, passing. All right. So because this is 1 second, there's another 1 second, so that it takes 2 seconds to pass James Bond. How long would it take to hit the ground? Well, hitting the ground is going to be further down. So because of that, we have to take the calculation and then set the height equals 0, because you need to know what's the height. Well, when it hits the ground, that means the height is going to be 0. So what I did is I put in E0 for H, and I pull out negative 16, which is right here, because they all have 16 in common right here. Pull out 16, and I got t squared minus 2t minus 15. And I know if I break it down 1 and 15 and 3 and 5, I can get a negative 5, and positive 3 will give me the negative 15 and negative 2 in the middle. And then if I solve it, I will have a t using the using the zero product property that what we did before, and then t equals 5 or t equals negative 3. So t stands for time, so therefore there's no way we can have a negative 3, so the only correct answer is 5. So to answer the question, it will take 5 minutes to hit the ground. And that is the notes for today. That concludes the notes for today. Thank you so much for watching.